Right, so thank you for coming. So today we'll be talking about the routing on Mikrotik, okay, and about this agenda today. So today we'll be talking about because previously we planned to talk about the dynamic routing on Mikrotik, yeah, but later on, because we thought that this is advanced topic about OSPF, about dynamic routing, about the BGP. So we think it is a good idea to discuss the basic stuff first. Okay, so once this done, and then we can talk about the routing further. Okay, so the agenda for today, it's a very essential stuff for understanding routing on networking. So talking about the introduction, routing basics, routing on Mikrotik. So we'll be covering both static routing and dynamic routing. Okay, some examples and question and answer. Right, so about the GLC itself, we are an Indonesian company based in Bandung, certified partner for Mikrotik, Ubiquiti, and Linux. Okay, you can just Google our name, GLC Networks, and then check in the website. Okay, about the webinar itself, so I'm a little bit fast today because I need to do something right after this. Okay. About the GLC webinar, it is a sharing event for from us. We discuss various topics, not limited to Linux networking, wireless database, whatever. Yeah. Regular schedule is every 2 weeks, irregular schedule as needed. And we start our webinar since 2010. My name is Ahmad Mardiansyah. I'm based in Bandung. A Linux user since 1999. Yeah, Mikrotik user since 2007. Ubiquiti user since 2011. Certified trainer for Mikrotik, Ubiquiti, and Linux. I'm a contributor for my own websites and other websites as well. And if you have LinkedIn, we can connect. Okay, so about yourself, I think thank you for introducing me some about your stuff here. Okay, so let's discuss the topic here about the routing basic. Yeah. So what is router? Well, a router is a network device. Okay, so it's a device that is used to forward packets. Okay. So router looks like this, okay, a square, but as an icon it looks like this. Okay, it's a little bit round with the arrows coming in and coming out. So router is layer 3 device. So what's that mean, layer 3 device? So that means they will work on layer 3 header. Okay, so whenever packets comes in, whenever a frame comes in, so router is not checking the frame, okay, because the frame is already dedicated to the router. So when the frame arrive, so the frame header will be removed, and then it will left the the packets, and then the packet itself has its own has its own pattern. Okay, so as you can see here on the left is IPv4, and then on the right is the IPv6. Okay, so that's router. So router is checking on this header. Okay, all right. So if you have any questions, feel free to do so. Right, about the typical connections. Okay, using router. So usually when we set up a network, it looks like this. So we have 3 routers here, router 1, router 2, router 3, and then between this router we have a switch. Okay, router 1 itself has its own network. So usually they are connected to a switch. So router 1 connect to a switch here, and then other computer will connect to it. Okay, so router 3, for example, is a wireless network. Okay, so their clients will be connected through wireless. Router 2 has its own network. Okay, so the purpose here is the router connects layer 2 segments. So as you can see, we have 1, 2, 3, 4 layer 2 segments. Okay, so router works on layer 3. Okay, meaning on each layer 2 segment has their own network ID. So each segment has an identification, yeah. And then because we are talking about the layer 3, so there must be a network ID on each segment. Okay, so this segments over here on the left, on the top left, has its own network ID, and then the network on the middle here at the center that connects between 3 routers, router 1, router 2, and router 3, has its own network ID. Okay, router 2 has its own network ID, and then router 3 here, it connects to its own network, yeah, on the top right. Okay, so that's how. So if people say physical topology, okay, this is how typical physical topology looks like. So outside of the physical topology, and then we can summarize this, we can abstract this into a logical topology. So logical topology, we don't talk about the physical connections from this port to that port. So it is more on the logic side. Okay, so logically we can turn the physical topology into this one. Okay, we have router 1, because logically we are talking about layer 3. So router 1 should connect to a network here, and then the network here is 192.168.1.0/24, and then we have a network in the middle, which unifies, which is a hub, or where the 3 routers are connected. Yeah. So the network in the middle here, 192.168.0.0/26. Okay. So we have another a network also from router 2 and router 3. Right. Okay. So as simple as that. So every interface on router, and so addressing is important here. Okay. So every router interface must have an IP address that belongs to that network. So for example, in router 1 here, so router 1 has 2 IP addresses, so 192.168.1.1, okay, it says on the left, and then 192.168.0.1, okay, that's for the network here, okay, on the right. Now, okay, so I got the message here from Mardiansyah. Okay, so hope you enjoy this English webinar. So if you have questions, just feel free to do so. Just type your question here, and then I'll try my best to answer that. Okay, so typical connection. So we have logical topology here, and then the routing table. Okay. So as you can see, on each router we have a table. So that table we use that table in order to forward packets. Okay, so every time a packet's coming in to the router, and then the router will use this table to forward the packets. Okay, so this routing table must be available on every device, not only router, but also available on end device like laptop, your smartphone. They must have a routing table. Okay, so entry here is executed sequentially, entry on routing table. So because of course we have what is it, so entry is executed sequentially, and because it's sequentially, so you must have what is it, a priority how to rearrange the table. Okay, I have a question here. Is it materials for static routes? Well, this is routing basics. Okay, so it's nothing to do with static route. So so it doesn't matter if you're using static route or dynamic routes. So the thing is, on every router they must have a routing table, and then you need to understand how the routing table works. Okay, so as you can see here, we need to set up a priority on routing table. So because there are so many entries there, yeah, So router will rearrange the routing entry and then put priority. So okay, so if they put priority, there must be a rule to set a priority on the routing table. Yes, 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 yes. What are the priorities? So first, longest prefix wins. Okay, so it means that the longer the slash here, okay, that means the network is much more specific. So that means if your destination IP address is falling into that, and then we will use that entry. Okay, so the number one, longest prefix wins. Okay, see if both are same, and then we will use the lowest distance. Okay, so first is the prefix, and second is the distance. And 000 is known as default route, and then you should know that this default route, even though it's called default, it is lowest priority. As you can see, we have two tables on the left before we set up priority, and then after we set up priority, it is made like this on the right here. So as you can see, the longer the prefix, as you can see on the first rule here on the right table, 192.168.16.3/32. Okay, we should put it on top of the table. Why? Because it's /32. Yeah, so the longest among others. Okay, so how routing table works? Well, it works like a firewall, so much in action. So you should think in binary to understand how it works. Okay, so previously we already know that we have this routing table, okay, on the right, and then now we discuss how it works. Okay, so I really suggest you to think in binary, so in order to avoid the confusion. Okay, so for example, we have a routing table like this, and then the first routing table is 192.168.16.3/32. So it means that so IP address length is 32 bits, so we just put 32 bits here on top. Okay, and second entry is /26, so it's going to be like this. Okay, so the first 26 bit should match with the pattern here. And then the third entry is 192.168.1.0/24, so it's going to be like this. Okay, so we convert the 192.168.1.0 into the binary format. Okay, so why don't we just put the whole number here, 32? No, because here in this entry we just use /24, so it means that we just only match the first 24 bit of the address, okay, of the network. And then the last one is the default gateway. If everything has no match, and then we just send them here. Okay, so once again, you should know that the default route actually has a very low priority compared to others. So for example, yeah, so a package arrived at router 1. So the destination address is 192.168.16.3. Okay, so which gateway do we use to forward this packet? Okay, so always think in binary. So we should convert 192.168.16.3 into the binary. So it's going to be like this, right? Okay, so let's match. Okay, 192.168.16.3. Okay, try the first entry here. Is it match or not? Okay, blah 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 blah. Okay, so it matched. Okay, so the binary here on top is similar to the first entry of the routing table. Okay, so this one is matched, so we'll pick the gateway 192.168.0.2. Okay, done. What about the rest of the routing table? So we don't execute them. So once the packet is matched, and then we use them, and then forward the packets, the packet leaves the router, and then the first packet already processed. Okay, so as simple as that. So what happens if there are 1 million packets coming in 1 second? So this routing table will be read every in 1 million times. So that's why you need to have a higher processor on the high load router, okay, high traffic router. Okay, is this example 2 here. So our destination now is different, 192.168.2.6. Okay, so which gateway do we use? Okay, so first, so we need to convert 192.168.2.6, so it's gonna be like this, okay, 1100 blah 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 blah. Okay, so we convert the destination IP address into the binary format. Okay, so let's do the routing table lookup. Okay, check the first entry, is it match? Blah 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 blah. No, it doesn't match. Okay. Oh, okay, so let's try the second one. Okay, blah 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 blah. Oh no, doesn't match. Okay, try this the third one here. 192.168.1.0. Okay, blah blah blah. Oh, okay, it doesn't match. Yeah, it doesn't match. Okay, so entry number 3 is not is ignored. Okay, so it's gonna be the okay, let's try the fourth one here. Fourth, okay, entry number 4, 192.168.2.0. Okay, so oh yeah, this one match. So for this packet, we will forward to gateway 192.168.0.2. Okay, thank you very much, Muhammad Reza. Your answer is correct. Right, now, so we have a third example here. Now we are sending 192.168.6.8.6. So which gateway do we pick? Okay, try this one. Doesn't match, doesn't match, match. Okay, so well, so which gateway do we use? The last one here, okay. The default route. So as you can see, default route is execute very last. Okay, so the last one, it's the default gateway, the last priority. So if there is no other rules match, yeah, if no match on other rules, and then okay, just send them there. Okay, that's the default gateway. Right, so next is we're talking about the administrative distance. So previously you already talked about the prefix length. Okay, so the longer the prefix, the more specific, the more priority it has. Right, so administrative distance analogy. So you are in the crossroad. So you have options. You want to go forward, okay, turn left, turn right, and then okay, turn back. Okay, so I have one question here. I'm still don't understand about the binary. So can we just calculate the prefix? Yes, so it's up to you. Okay, so in my opinion here, so I'm thinking like a computer. Okay, so as you can see, a packet arrives at router 1. Okay, so how because router is a computer, right? So the way they do is they always thinking in binary. Okay, so whenever a packet's coming, and then the destination packet, the destination IP address of the packet is 192.168.8.6. So so everything is binary in computer, right? So you should turn this the destination IP address here 192.168.6.8.6 here into the binary. Okay, so 11000010101000. Okay, so whatever. So you should convert the IP address, okay, in decimal format into binary format. Okay, and then check on every entry on this routing table. Okay, so check the first entry. Okay, so the first entry says that if it is match on 192.168.16.3. Okay, if match that, and then use the gateway. Okay, so you always check based on the routing entry. Okay, so always thinking binary. So for me, I think it's easier. Okay, I think it's easier if you're thinking in binary, because computer is thinking in binary. Okay, so if you want to know how routing table works, they always think in binary. You should think in binary too. Yeah, so yeah, that is for easier understanding of routing table. Okay, back again to the topic here about administrative distance. We have a different gateway, so we have a different destination, and then we have different gateways on the left, see, with the arrow, green arrow. So Jakarta means you want to go to right, Bandung go straight, or you can turn left. Surabaya turn left. Semarang you have to turn around. Okay, and then so on the left here, on the table, top left table, is the distance. Okay, so yeah, so which one do you pick if you want to go to Bandung? Okay, so Bandung is same destination. Okay, Bandung, and you have two gateway to go to Bandung: go straight or go left. And then so on each way, on each gateway, we have a different destination. We have different distance. Okay, so if you go straight, okay, eventually you will arrive in Bandung with 120 kilometers distance. Okay, and if you turn left, it is 90 kilometers. Okay. Okay. Anything else? Okay, no. Right. So let's continue. Oh, sorry, I have a little bit issue here. Right. So no problem. So table on the left here. We will turn into the table on the right. Okay. So let's say Jakarta is 10.10.10.0/24. And then the gateway is 192.168.0.1. Okay, Bandung is 10.10.20.0/24. Okay, and then Surabaya is 10.10.30.0/24. Semarang. Okay, they have a different gateway here, and then we set up the distance, administrative distance. So as you can see, all prefix here, okay, all destinations here is using the same prefix length. Okay, their subnet is same. Okay, /24. Okay, so all of them are /24. Okay, so which one do we pick? Okay, so let's say if you want to go to Bandung. Okay, so all of them, we have two entries here. Okay, which one do we pick? Yeah, we pick the one with the lowest distance. Yeah, in this case, the distance is 9. Okay, so based on this table, we can provision the table into the Mikrotik router. Yeah, so if you want to display, so IP route print. Okay, and then that's how routing tables on Mikrotik looks like. Right, so I hope you understand about that administrative distance. So distance is considered when prefix length is same. So it's the seconds parameters that is considered. Okay, lowest distance wins. Administrative distance policy, it depends on the vendor. Okay, so Huawei, Mikrotik might have a different policy on administrative distance. Okay. Table on the right here is shows an example of administrative distance on Cisco router. Okay, so about the routing itself. So as I said previously, this one is for example. So on every router, you must have a routing table. Okay, so it doesn't matter if you have if you set up a routing table by yourself, that is called static routing, or you can use dynamic routing, doesn't matter. So the thing is, on every router you must have a routing table. Okay, so when we open router 1, we can see there is a routing tables on router 1 here. Okay, so it shows that, okay, if I want to go to this destination, and then here's the gateway I pick. Okay, so entries on routing table is created manually. So in this slide, we're talking about the static routing. So static routing means entries on routing table is created manually. So because in this network we have 3 routers, and then it's easy for us. We can log into router 1 and then set up routing. We can log into router 2, router 3, that's fine. But if we have 3 routers, it's fine. But if we have 13 router or 30 router, well, it's gonna be a not good. Okay. So admin must manage routing table in all routers. So you have to log into every router and then provision the static routing. Okay. So, but there is a benefit on static routing, yeah, because as an admin you have a full control of your routing table. Okay. Other alternative than the routing table, static routing is a dynamic routing. Okay. So that means the entries on routing table is provisioned automatically using routing protocols. An example of routing protocols are RIP, OSPF, BGP. Okay, other routing protocols like MME, um, whatever. What else? EIGRP if you're using Cisco. Okay. So the thing is, admin must have a good knowledge about routing protocols. Okay. So it is important to know. Okay. So currently, with the current technology, routing is done one way only. Okay, so routing is one way. So from source to destination. Okay, so routing is only one way. So forwarding, so currently, so I'm talking about currently, but there is a possibility of doing routing based on the source. Yes, I mean maybe depends on the destination and the source. Okay, so forwarding process on router is based on the destination address. Okay, not the source address. So the router only check the destination IP address and then do the forwarding decision based on that. So therefore, there is no guarantee that incoming path is similar to outgoing path. So for example, here we have a path from laptop to the laptop. Okay, laptop on the left, laptop on the right. So we have outgoing path here. Okay, so from laptop to router 1 to router 3, router 3 to the laptop on the right. But on the reply, okay, so from the reply is laptop on the right goes through router number 3, router number 3 to router number 2, router 2 to router 2 to router 1, and router 1 come back to the what is it, the original laptop. Okay, so there is no guarantee. Again, there is no guarantee incoming path is similar to outgoing path. Okay, so it really depends on the situation. Okay, because we cannot control. Okay, we cannot control. So every router can only control its own router. Yeah. So therefore, we can only control outgoing forwarding. Okay. For incoming, we just passive. We just a passive network device that receive packet from somewhere. So we can only control the outgoing forwarding. Okay. So next, routing on Mikrotik. So we need to know where the routing table lookup happens. Well, it happens here. So if you open the Mikrotik packet flow, okay, so you will see like this. Okay, so from input interface, checking is input interface a bridge or not. If not, and then go to pre-routing. From pre-routing, and then we do the routing table lookup. So we read the routing tables on this stage, okay, on routing decisions. So the results of these routing decisions, we have two. We have input and forward. So if the packet is passing the router, and then we go forward. If the packet is destined to the router, and then we use input. An example, yes. So if you ping the router, okay, so you ping space blah blah blah, and then the IP address that you ping belongs to the router. Okay, so you ping to the router itself. So for example, you open a Winbox, you open a webfake, you telnet to your router. So it's categorized as input. Okay, it will count as input. But if you ping Google 8888, if you ping, I think there is a one DNS server 9999. Okay, so those addresses are not belong to the router. So the router will forward the packets. So that means you will use forward. All right, so that's where the routing table lookup happens. Okay, so static route on Mikrotik. Static route means routing entry is provisioned manually. So if you want to add the default route here, so this is the command IP route at destination address is 000/0, and then you put a gateway. You can set up distance as well. Okay, let's say 250. Yeah. Why 250? Because as you can see here on administrative distance, okay, so all other routing tables are low. Okay, so if you put the, for example, 250, so it's gonna be like this. Okay, and then yeah, so you can run your other routing dynamic routing protocols, which has lower distance compared to your default route. Okay, so your default route will be ignored by this routing protocol, okay, because you put the higher distance. Okay, so that's the reason why you put the distance here. Okay, when you set up a static route on Mikrotik is for example 250. Yeah, so that when you run the dynamic routing protocols, they will they will win. Yeah, because they have a lower distance compared to your static route here. Okay, so if you want to add a second example here is when you add a more specific route. For example, destination address is 192.168.2.0.624. You set up a gateway, okay, set up the distance, and then check the gateway. Okay, so this check gateway option is important. Yeah. So otherwise, Mikrotik will not check the gateway. Okay, so they are still keep sending the routing, the forwarding the packets into the gateway, even though the gateway is already off. Yeah, because you don't activate the check gateway option. So it's very important. Either you can use ping or R. Okay. So next is dynamic routing. In this case, we use RIP. Yeah, so we add the RIP interface. Here's the procedure. Okay, so first you add the RIP interface. For example, in this topology, we use ether1 and ether2. So we had both of them into the RIP interface, and after that we add the network to advertise to other routers. Okay, so we add the networks that we want to advertise so that other routers knows where to go. So in this case, we have two networks, 192.168.0.0/26, and then we have 192.168.1.0/24. Okay, so yeah, so as simple as that. So once RIP is running on every router, each router will send its own routing table to neighbor routers, and then the neighbor router will send their own routing table to you. Yeah, so it's like a back and forth. This routing table update happens periodically. So if I'm not mistaken, so RIP will send a routing table every 30 seconds. So when all router gets full routing tables of the network, so we call this as a convergent state. Okay, so all networks get the whole picture of the network. Yeah. Well, I think that's all. Thank you very much. Yeah. So if you're interested, just come to our training. So why come to our training? Because the topics are arranged in systematic and logical way. You will learn from experienced teacher, so, and you'll not only learn the materials but also sharing experiences, best practices, and networking. Okay. So this is end of slide. Thank you very much for your attention. Submit your feedback. Okay, bit.ly feedback here, like our Facebook page. Okay, slide will be available on SlideShare, and then recording will be available on YouTube. Okay, please stay tuned with our schedule, and thank you very much for listening. Okay, if you have any question, sorry. If you have any questions, and then just type it here. Okay, any questions? Any questions? Okay, so hopefully you understand about the concept of routing. Okay, because routing concept is really important when you are doing network administration. Okay, so once you understand the concept of routing, so it doesn't matter the brand. Okay, you can use Mikrotik, you can use Ubiquiti, you can use whatever. Yeah. So all of those network devices are sharing the same concept. Okay. Well, if you don't have any questions, and then I will say we can close this meeting. Yeah. Well, once again, thank you very much, and then see you again. Bye bye.